Hey guys, and welcome to the Jidoka Basics section of our Jidoka series. Now, in this section we'll be going over automation, autonomation, as well as some visual controls. But before we get started, me and my dog Apple will give you a brief intro into the subject. If you've watched the rest of the videos on this site, you've probably guessed that I have very few friends and even fewer visitors. Because of this, Apple is not very well socialized when I do have an occasional visitor. My two regular visitors are the maintenance man Jack and parole officer Jenkins, both of whom Apple has bitten. In this case, Apple biting someone can be thought of as a defect getting through to the customers, Jack and Officer Jenkins. So my first step was to buy a kennel and to lock Apple up whenever a visitor came to the door. But on several occasions he got out and the biting continued. There's about 30 feet between Apple's kennel and the front door. So I decided to put a motion detector and alarm about 10 feet away from the door so I could tell if Apple was coming. This reduced the frequency of the bites, but they still continued. So I decided to move the alarm back 10 more feet so I'd have more time to react when Apple got out. This again reduced the frequency of the bites, but there were still some getting through. I decided to buy another detector. I put this one 10 feet away from the door. Now I have two alarms to help me react to Apple getting out. As you probably guessed, this step reduced biting, but there were still some bites getting through. Notice that all the alarms I put in place were simply detecting defects. They did nothing to prevent them. I could, in theory, put an infinite number of motion detectors between the door and Apple's kennel, and there would still be some opportunity for Apple to get out and bite. If I want to prevent defects, I'd have to go back to the source. The source is the process I use to lock Apple's kennel. If I mistake-proof this process, then I actually wouldn't need any motion detectors. Building quality into a process to prevent defects is a major component of Jidoka. So Jidoka translates to automation. Now don't go looking for automation in the dictionary. It doesn't exist in the English language. It's a play off the words autonomous and automation. Toyota combined these two terms into Autonomation to describe the word Jidoka. The word you see here is the kanji, or the Chinese characters for the word automation. This is the kanji for Autonomation. Do you spot the difference? The difference between these two words is the man, or the human character. When you insert the man radical into automation, it becomes what Toyota calls Autonomation or Jidoka. So that's why Jidoka or Autonomation is often called automation with a human touch. Jidoka implies two things. First is the clear separation of those tasks that should be performed by a man versus those that should be performed by a machine. Machines are great at performing repetitive tasks, but lack human intelligence. In contrast, humans are great at using their brains, but often grow bored or produce errors when given repetitive tasks. With each step in your manufacturing process, you should ask, does this person really need to be on the machine for this process to work properly? Are we just wasting a valuable thinker by making him sit here and wait and watch the machine? Focus should be put on building intelligence into machines so you can free up your most valuable resources, your operators. Remember the looms that Toyota used in the textile industry? Intelligence was built into the machine so they would stop once they detected a thread break. This way, workers were freed up to perform other meaningful tasks rather than sitting and waiting. Now that you have a good understanding of what machines are to do versus what operators are to do, it's time to start building quality into the source of both man and machine tasks. How can we prevent errors rather than just detecting them? When toasting bread, I used to sit there and watch the toaster until it was finished. This is because my toast could burn, so it was my job to stop the toaster when it was just right. Luckily, the manufacturer understood automation and built human intelligence into the toaster. The timer on the toaster allows for a clear separation of work between me and the toaster. Now all I'm responsible for doing is loading and unloading the toaster. The toaster is smart enough to stop toasting when the bread reaches the time I set. Now I'm free to perform other tasks while the toaster is working. Think for a moment. Do you have operators that sit in front of machines with little to nothing to do? Is their primary job to sit and wait for errors to occur? Is there a way you could build human intelligence into the machine just like the timer on the toaster so you could free up that operator? I've seen many cases where it was an operator's primary job to sit and watch a machine run. This is not only a complete waste of talent on the part of the company, but also an insult to the operator. This also poses a secondary hazard to the company. Given this scenario, over time, operators shut down mentally, which breeds laziness in the workforce. Failing to explore automation is a lose-lose for both the operator and the organization. So back to automation versus automation. The primary goal of automation is to replace workers. Unfortunately, automating a process is rarely successful. This is because automating operations that a human used to perform often still require the machine to be monitored. So whereas the process took an operator before, it now takes a machine and an operator. The cost model is higher with automation. In contrast, automation builds human intelligence into the machine, so an operator is no longer needed. As you can see, this model is cheaper than the original manual process and the automated process. There are 3 levels to Jidoka. They are recognition, action, and prevention. The first step to intelligent automation is to build a mechanism into the machine that detects defects. Depending on what you are manufacturing, this can be as sophisticated as a computer vision system or a simple latch that is tripped when a part is larger than spec. At this stage of Jidoka, the machine detects an error and performs an action to let the operator know a defect has occurred. A flashing light or an alarm lets the operator know the machine needs to be shut off before more defects are generated. At this basic stage of Jidoka, an operator is still coupled with the machine. Next is action Jidoka. At this stage, the machine not only has a mechanism for detecting defects, but it also has the ability to segregate defects into a separate bin from good parts. This prevents defects from making their way to the final customer. At this stage, an operator is not needed to run the machine, but may be needed to properly dispose of defective parts and make adjustments to the machine to prevent more defects from being generated. In the previous levels of Jidoka, the machine reacted after defects were generated. In prevention Jidoka, the machine takes action before defective products are produced. The machine continuously samples parts and checks for statistical shifts or drifts. When it senses a product moving toward a spec limit, it makes adjustments to correct itself before defects are produced. In this case, an operator is rarely, if ever, needed. Ideally, at this stage, a lot of poka-yoke, or mistake proofing in English, is built into the machine. An example of this would be to weld down certain adjustments so they physically cannot shift during long hours of operation. So what do I mean by poka-yoke? This is a real example from the shipyard. Welders used to mix gas and air lines on their welding machines. This not only caused downtime, but was also a potential safety risk. So we color-coded the fixtures and the tips for the gas and air lines. This reduced the errors, but they were still occurring. So we color-coded the entire lines. This again helped, but didn't prevent errors from occurring. We finally made gas fixtures male and air fixtures female to poka-yoke this process. Gas and air lines physically could not be mixed up anymore. So here's an example to show the 3 levels of Jidoka from my time working in the printing industry. Have you ever noticed these markings on products you buy? This happens to come from the bottom of a yogurt box. They're used by the company that prints the box to control their quality. Here's how it works. Each color on this box is printed one at a time. Each tower on a printing press is loaded with that particular color ink. Once the paper makes it through the entire press, the image is complete. Each time the image passes through the tower, it also prints a small square of the same color on the edge of the sheet. If the squares line up, it means the image is in spec. If one or more of the colored squares don't line up, it means the printed image is defective and must be discarded. So at the recognition level of Jidoka, the machine would detect the color box being out of the expected area and sound an alarm for the operator to stop the machine. In the action level of Jidoka, it would warn the operator and then send those defective images to a separate waste bucket. In prevention Jidoka, the image would be continuously read by a camera system. A sensor would send the signal back to whichever print tower is drifting out of spec and adjust it before defects were generated. Now, if this particular printing press was dedicated to this product, then print stations could be fixed so they literally couldn't move out of spec. This would be an example of poka-yoke. So this gives us a good idea of how intelligence can be built into a machine. This addresses the machine portion of Jidoka. But remember, we separated manual and machine work. So how do we build quality into a manual process? The actions are just like those in the machine portion. The first thing to do is to have operators clearly recognize what is considered defective. The next step is to create a standard procedure for dealing with defects. In this case, a yellow bin is placed at each workstation. If the operator is given a defective product from the previous workstation, he places it into the yellow bin. The product is either corrected by the operator, a team lead, or is discarded. The last level is prevention. Remember when Station 1 in our simulation was generating the majority of the defects? We put in a jig that would make it nearly impossible for the worker to make an incorrect fold. Finding ways to use jigs and fixtures, or better yet, to fully poka-yoke the process is the final step of manual Jidoka. So one of the best and easiest ways to control quality is using visual controls. This is because they're intuitive. This is a visual control I noticed at an Asian supermarket I shop at. They have pictures of what goods are stored inside each freezer. Not only does this save electricity, but it also keeps me from needing to open each of their many freezers to find what I'm looking for. It also helps the store workers when they need to replenish items. Next is an example I found at the DMV. We all know they need all the help they can get. When I walked in, I was given a number. They had a visual board that showed which line I was to go to. The visual sign showed everyone they were being served in order and helped keep visitors organized. I saw this example at a barbecue place I like. The hostess had a dry erase board to show which tables are occupied. This keeps the area organized and the hostess knows where to sit the next party. They also used this interesting visual control. If I needed service, I would turn the card this way to show any waiter passing by that I needed something. If I was doing okay, I'd turn the card around to expose a pig with the sunglasses to show I didn't need service at that time. Here's an example that's similar to the DMV model. At virtually all Korean restaurants, they have a button for service. When I'm ready to order, or I need a drink refilled, I press this button. It sounds a bell and lights up the table I'm at. This lets the waitress know that her help is being requested. I like seeing these inside restrooms. They let me know that the restroom is being serviced regularly. They reduce errors because they show specific tasks to be performed. Without a list like this, it would be easy to leave something out. The initials at the end of each line also drive accountability. Any manager can take a quick glance over the sheet and see that all tasks are being completed. I saw this on the back of a register at Target. I liked how the cords are color-coded. You can take a quick glance and notice if the cords are plugged into the wrong port. It looks like FedEx and UPS are also using visual controls. There's an indicator on the outside of their drop-off boxes to show if the mail has gone out that day or not. This not only helps the employees servicing the boxes, but also helps individuals that may be in a hurry and want their package sent out that day. This visual indicator will let them know if they need to drop off their package at another location. This is from the pretzel place at the airport. They use visual controls to ensure the employees are making pretzels to the correct size. This not only serves as quality control, but also cuts down on the training time needed for employees. The final example is from my housing community. The guard hands out colored passes for visitors. The passes are never the same color 2 days in a row. This lets guards know which cars have exceeded their 24-hour allotted stay. A quick glance over let them know which cars need to be towed. So we made a big deal about defects and defect prevention. So what's the big deal? Why is it so important to catch defects right when they happen, or prevent them from happening in the first place? Couldn't we just correct defects later? Well, here's an illustration. Russian dolls look something like this. The smallest one fits into a larger doll. That larger one fits into an even larger one. This process continues until you're left with one large doll with all the smaller ones contained within it. The issue is, if you have to make an error and it's not caught immediately or by the next station, the defect is hidden within the product. Once it's buried within the product, just like this Russian doll, it literally can't be seen and can't be fixed. The next person to find that error will be your final customer. Defects come in many forms. Here's an example of a real-life defect I encountered. On a trip to my parents' house, I decided to do a little bit of maintenance work on my mother's car. Among other things, she needed new windshield wipers on her 2005 Civic. So I went to the automotive area at Walmart. As you can clearly see, the book calls for 24 and 19 size wipers. This seems a bit odd because the driver's side seems longer than the old one I brought in. But I trusted the book, and this is what I came up with. Did they expect me to wipe the windshield of the car next to me? I walked back in highly frustrated and compared the Walmart database to the manufacturer's book, and they don't match. The Walmart version actually seems to be more accurate to my old blade because the sizes match when I line them up. I finally make my way back to the car, and the size that the Walmart database suggested works. So while the product itself wasn't defective, the manual was. Keep in mind that defects come in many shapes and sizes, and it's your job to protect your final customers from finding them. At the beginning of the lesson, I showed you how Apple getting out of his cage and biting is a defect. Putting checks in place to detect errors is only the first step. You have to build in quality into the root of the process if you want to prevent errors and not just catch them. So here's a quick summary of what we learned. we defined what Jidoka was, we saw some examples of Jidoka, and then you saw some real-world visual controls.